Hello, welcome back, everyone. Today I'm going to be talking about measures of spread, right? So, quartiles and also percentages. So, basically, last time we talked about measures of central tendency. So, we wanted to figure out, where was the middle of the data set and what best method to use in order to find that most accurately, depending on the type of data set we're looking at. In this case, we're going to talk about the spread of the data. So, where does most of the data set lie? Right? Some data sets are very random and kind of have data all over the place. Other sets of data are, very confined to one main spot and just have a couple outliers. It kind of just depends, right? So we need to know not just what's the median, for example, but, you know, not just the number of people, not just the number where 50% of the data points are above, 50% of the data points are below, but what about the point where 25% are below and 75 are above? What about the point where 75 are below, 25 are above? Those could also be useful numbers too. How about the minimum and maximum values overall, right? Those are also going to be useful, knowing that nothing can go below the minimum and nothing can go above the maximum, right? In terms of knowing how the measure, how the spread is, all of those things matter. So first, I'm going to talk about the box and whisker plot. So a box and whisker plot is a visual display of data on a number line by organizing the data into four different sections. Okay, so section one, first thing is the minimum or maximum value. So let's say this is our min value. Oh, min value. And then this over here is going to be our max value. Let's say our median is over here somewhere. Let's say this is our median. And this is Q1 and this is Q3, right? I should say also Q1 is lower quartile and Q3 is the upper quartile. Okay, and median is also known as Q2, so to speak. So basically, the bot and whisker plot tells us where the minimums and maximums are, so where the endpoints are. It tells us where the median is, and it also tells us at which points, are we 25% of the way into the data and 75% as well, and also, of course, 50%, because that's the median. So, lower quartile is the median of the lower half of the data set, or in other words, 25% of the way into the data set overall. The upper quartile is the median of the upper half of the data set, right, which is also the 75% mark, right, where we're 75% of the way into the data, or 25% in from the right of the data. And then the interquartile range is the difference between the lower and upper quartile, right? So if I was to do Q3 minus Q1, I would get the interquartile range. And that tells us that, 50% of the points lie in that range. And then 25% are below that range, 25% are above that range. So that can be a useful number. Quartiles are the four sections of this box plot and whisker plot, and each quartile represents 25% of the data, right? So we have this section here, which I'll highlight in blue, which is the first 25% of our data is represented between the minimum value and the lower quartile. Then we have another 25% represented between Q1 and the median. Then another 25%, which is above median but still less than Q3. And then we have a fourth one. Let's grab a different color, which is the top 25% of the data points, which could be good or bad depending what it is we are measuring, right? If we're measuring how many times someone's been arrested, probably not so good. If we're measuring the grades, we want to have a higher grade. So being, in that upper one is better, right? So these are not necessarily better or worse. It really depends on the situation. These are just showing where the data is at given the data that we have. Awesome. So now that we understand that, let's give some examples. Example one says, during the number of wins during the last 13 seasons by the Buffalo Bills is 6, 4, 6, 6, 6, 9, 8, 7, 9, 6, 10, 13, 11. Draw a labeled box and whisker plot for the data. So keep in mind that in order to do that, we first must figure out the median, then we must find the upper and lower quartile, and we also must find the the minimum and maximum. Now, the minimum and maximum might be quite obvious that the lowest number was 4 and the highest is 13, but we've still got to find the other numbers. Okay, so let's go ahead and do that. So first things first, I'm going to order these in the correct order, right? So that means I'm going to put them in the order from smallest to largest. So 4, 6, 6, 6, 6, 6. Yeah, it's 1, 2, 3, 4, 5. 6 is 1, 4. Do we have a 7? We do have a 7. So 7. We do have an 8. So 8, 9, 9. We do have 2 9s. We got a 10 and an 11. And we've got a 13. Awesome. So now we're going to find the median, the middle number. Okay, for this one there's 13, so I'm actually not going to use this method anymore. I'm going to say, well, 13 plus 1 divided by 2 is 7, so therefore it must be the 7th number, which the 7th number is actually also 7. So by the way, that's just a coincidence. The 7th number was also 7. The number of data points we have to go in is not necessarily going to equal the actual point there, but it does in this case, coincidentally. Next, we're going to find the median of the lower part of the data set, right? So in this case, we have 6 numbers here. So the middle ones are these two 6s. So Q1 would be 6. As for over here, it would be 9 and 10 would be the middle two numbers, so we'd have 9.5. So now I'm going to draw the box and whisker plot and label it. So we need numbers from 1 to 13 on our bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'll label those. And so our lowest is 4, so I'll draw a dash there, and our highest is 13. We could say 14, 15 on the number line, but doesn't matter. We really just have to get up to 13. Then our Q1 is over here, so bigger line there. And then our median is here. And then our Q3 is here. And then now I'm just going to fill that in and say, there we go. Perfect. Good. Very, very good. Okay. Well, there we go. And there's our plot. Let's say they asked us for the interquartile range. Well, they didn't actually ask for that, but if they had, we would just say it's 3.5 because we would take 9.5 minus 6 and get 3.5 from that. So that means that the range of data, from 6 to 9.5, that 3.5 range there accounts for 50% of all the data points, the middle, that middle 50% of the data. Very good. All right, so let's move on. We have a few more questions here. This next one asks us, it says, the resting heart rate in beats per minute of a group of 10 people is these values. Draw a labeled box and whisker plot for the data. All right, so in this case, I'm going to kind of do the same thing I was doing before. I'm going to write out these numbers from smallest to largest. So let's see, what's the smallest number? I think it's 56. That's the only thing that's in its 50s here. What about 60s? We have 64, and actually I think that's it for 60s too, just 64. What about 70s? Looks like we have 75, 78, and 79. Okay, and then what about 80s? We have 81, 85. And then we have 94, 94, 96. Like that. Amazing. Very good. There it is. All right, so there's our data set. Now we must find the median. So for this one, the middle numbers are going to be what? Well, it's an even number, so it's going to be 10 divided by 2 and also 12 divided by 2, which is 5 and 6. So number 5 and 6 are these two here. And what's the average of 79 and 81? Well, it's going to be 80. So 80 is our median. Then we must figure out what is the, what are our lower and upper quartiles. So in, over here on this side, looks like we have 5 numbers in this half here. So our middle of these is going to be 75. And then our middle here is going to be this 94. And so there we have it. All right, so for this box and whisker plot, our minimum is 56 rather. And our maximum is 96, right? And then we have, looks like 75, and then 80, and then 94, and then finally 96. This isn't really drawn to scale, but that is okay. Well, it wouldn't be okay for an official report, but for a rough drawing, it would be okay. But yeah, but that's the basic idea, right? Is that our median, this graph is to show that our median is 80, that our upper and lower quartiles are 94 and 75 respectively, and also that our minimum and maximum are 56 and 96 respectively as well. Very good. All right, let's do another example. And this example I like because it actually asks us questions related to the plot. So not only do we have to draw it, we have to be able to answer questions about this plot, and that's going to be useful as well. Because it's one thing to be able to draw this plot, but what good is this plot if we can't understand, what's what? What do these numbers mean? What does it mean that we have a lower quartile or upper quartile or things like that? What percentage into the data are we exactly, right? So that's also very key. Okay, so here it says the number of calories in Subway's top 10 selling sandwiches are 219, 248, 215, 213, 219, 161, 254, 232, 223, and 162. So first things first, we need to order these data points. So I think our lowest was 161 and 162. So let's write those. 161 is lowest, then 162. Do we have 170 something? No. In fact, actually, I don't think we have any other 100 and somethings at all. So let's move on to 200 and something. So it looks like 213 is lowest there. We also have a 215 and a 219. And are there any other ones with 2 and then a teen? Yes, there is actually. We have another 219, so that might be our mode. Not that this box and whisker plot has anything to do with mode, but if it did, that would be something to keep in mind, that's a possible mode here. Okay. And then we have 223s next, then 232, then 248, and then 254. So there we go. And it's 10 sandwiches. So that means sandwich 5 and 6 are the median sandwich, which is this one. The average of 219 and 219 is just going to be 219. So that's perfect there. And then what about the median of this half of the data? Well, that's going to be this one here is our middle. So 213. And then what about the the right half of the data? It'd be, I erased stuff by mistake. 232. 232, like that. So there we have it. So then I'm going to say, well, here we have 161 over here. Over here we have 254. Then we have 213 somewhere in there, 219 and 232. And then, there we go. Now we have our box and whisker plot. All right, so this next question asks, what percentage of subs have less than 213 calories? Well, let's review what these different quadrants mean. This first one is the first 25% of the data, right? And then this next one is another 25% of the data. This also is 25%. Then this one also is 25%. And then the last one is also 25%. So if we want to know just the part of the data that is less than 213, that's only going to be that yellow portion, right? That's only that first 25%. So therefore, my answer is 25%. And if we wanted to write a full sentence, we could just say 25% of subs have less than 213 calories. Good. Then it asks, what percentage of subs have more than 213 calories? Well, if 25% had less, then that suggests that 75% would have more. But in order to find that on the box and whisker plot, we would just have to add up this 25, and this 25, because all of these numbers on this number line are to the right of 213. And so therefore, all of them have more than 213 calories. So we've got to add up all three of those sections in order to get our answer. Then it asks, what percentage of subs has less than 219 calories? Well, here they're asking for everything to the left of the median, right? Everything to the left of 219. So the answer is clearly 50%, for a couple reasons. First of all, we know 219 is the median, and the one core characteristic of the median that completely defines it entirely is that the median is always where half is the number that's right in the middle, where half of the data points are greater and half the data points are less. So we know it's 50% from that. But also, we can look on this plot here and say, 25 here and plus 25 here. Oh, well, that adds up to 50%. So therefore, the answer's got to be 50%. So that's the other option there as well that we can do too. Well, very good work, everybody. That is it for the measures of spread, quartiles, and percentages. Next, we're going to talk about the standard deviation and the variance, which are very good key things we're going to have to learn. So this is an exciting, quite a tedious one, this next one, but it's an exciting one. It's definitely key in order to do any sort of statistics or anything like that. It's going to come up a lot in the future. So yeah. So we'll talk about that next time. Good work today, everyone, and we'll see you next time to talk about variance and, more importantly, standard deviation. Bye, everyone.